S. Chan presents educational video lectures. Difficult concepts made easy. Study anywhere, anytime.
There are the many ways by which we can distinguish between the insulators, conductors and the semiconductors. But one way or the easy ways that is easy to describe the conductor, semiconductor and insulator, that can be described by the position of Fermi level in the materials. So Fermi level in the material, that can be explained as
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box.
myself Dr. Narinder Kaur and welcome to S. Chand Academy. So let us begin how we can distinguish between the metals, insulators and semiconductors, so depending upon the Fermi level. So what is a Fermi level? Fermi level, it is defined as the highest energy level that an electron can occupy at the absolute zero temperature, that is known as Fermi level. Now what does it mean? So that means we know that in case of material, we are taking any material, this material that can be metal, semiconductor or insulator. So firstly the material, it can described into the three ways. So the material, it can be metal, it can be semiconductor, or it can be insulator. So the material that can be of three types: metal, semiconductor and insulator. So now we know that in metals, the materials have valence band and have conduction band. Valence band is that the highest occupied level, that is known as valence band of any material. So what is the valence band? Means material that is comprised of, basically we can see any material, it has different kind of bands: valence band, conduction band. What is valence band? It is defined as the highest occupied level, the highest occupied band or the level, that level is known as valence band. Now conduction band, it is known as the highest unfilled band in the given material, the highest unfilled band in the material, that is known as the conduction band. For example, if we are taking a hydrogen, so we know that the configuration of the hydrogen, that can be written as 1s1. So that means 1s1 means it has only one electron in its s orbital. Now when we are considering about the 2s, so 2s, it having a zero electron. So 1s1 means this s orbital, that is known as a valence band for the hydrogen. So this is known as the highest occupied band by the electrons in the given material. This is known as a valence band. While 2s, that is empty, then again there is a 2p, 3s, 3p, all that will be empty. And this is the lowest occupied level, so that is known as the conduction band for the given material. So that means we know that, so in the material, so it is formed by the valence band. Valence band, it is known as, in other terms, it is known as the highest filled band. Highest filled band mean, in the one material, if we are considering the 1 mole of hydrogen gas, so 1 mole of hydrogen gas means there are 6.023 into 10 raised by 23 atoms are present. In all and each every atom has one s orbital which is filled with one electron. All these s orbitals, they will superimpose on each other, so that will be explained by the band theory. And when these all s orbitals, they will superimpose on each other, they will form a one band. That band is known as the valence band. Next is, there is a conduction band. Conduction band, it is defined as the lowest unfilled band. lowest unfilled band means now 2s. This is known as the lowest unfilled band. So this band is known as the conduction band. Similarly, all the 1 mole atoms of hydrogen, they will have this vacant 2s orbital, and due to vacant this 2s orbital, all these 2s orbitals, they will superimpose on each other and they will form a band. That band is known as the conduction band, because behind that there must be 2p, 3s, large number of highest bands are also available. But we are taking the highest filled band is known as a filled band, valence band, and the lowest unfilled band, that is known as a conduction band. So now, depending upon the position of valence band and the conduction band, material can be divided into 3 categories. It can be metals, semiconductors, or the insulators. So that means now the material that can be defined as, so now first, in case of metals, valence band, and that is a conduction band. Means valence band and conduction band, they overlap with each other. When they overlap with each other, it is very easy for the electrons to jump from valence band to conduction band. Means atoms can easily jump from this to this level. So that is a case of metals. So that's why metals are known as good conductor of electricity. So there is, that means valence band and conduction band, they overlap with each other. So such kind of materials, they are known as the metals. While in case of semiconductor, there is some gap between the conduction band and the valence band. So there is a conduction band. Basically, the boundary of these levels, that is not fixed. So this boundary of these levels, that is a imaginary over here. While for the, so these are known as a semiconductor. That means for the semiconductor, there is small gap between the valence band and the conduction band. While in case of insulators, the conduction valence band and the conduction band, the gap between them is very large. So that means it is not easy for the electron to jump from valence band to the conduction band. So that's why these materials are known as insulators. So insulator means the gap between the valence band and the conduction band, that is very large, and it is not easy for the electrons to jump from this valence band to the conduction band. So that's why insulators, they are very bad conductors of electricity. The electricity cannot be conducted in case of insulators. While in semiconductor, it is possible for the electrons to jump from this end to this end by application of some energy. That energy can be in the form of thermal energy or the electrical energy. So in that case, electrons are able to jump from this to this end. Now there comes a concept of Fermi level. So Fermi level, because these level boundaries, these are not fixed over here. So now the highest occupied level in this case, that level is known as the Fermi level. So now in case of here, when they are overlapping with each other, so there come one level by which we can see that we are, this is the imaginary line, imaginary level by which we can separate valence band to the conduction band. This imaginary line or the imaginary gap or the band by which we can distinguish between the valence band and the conduction band, that is known as Fermi level. So in semiconductor, it is assumed that the Fermi level lies midway between the conduction band and the valence band. Similarly over here, it is assumed that the Fermi level, it lies midway between the valence band and the conduction band. So this is all about the Fermi level. So what is the Fermi level? So it is defined as the highest energy level with an electrons, that an electrons can occupy at absolute zero temperature, that is known as a Fermi level. So this is defined as a at absolute zero, because when the temperature is enhanced either in the metal, semiconductor or insulator, when the temperature is enhanced beyond some limit, electrons will jump from valence band to the conduction band. So that means the Fermi level, it will be shifted up. or when the temperature of the material, if it is very high and it get cools down, the electrons will jump back from conduction to valence band. So in that case, the Fermi level will shift it downward. So depending upon the temperature, the position of the Fermi level that can be changed. Then the Fermi level, it lies between the valence band and the conduction band, because at absolute zero temperature, electrons are all in the lowest energy state. Next, due to lack of sufficient energy at 0 Kelvin, the Fermi level can be considered as a sea of fermions, or the electrons, means that is the highest occupied level, below which there are all the electrons are present and above which there is 0 electron, because above which no electrons exist. The Fermi level changes as the solids are warmed, as the electrons are added to or withdrawn from the solid. So depending upon that, the Fermi level that can be changed. So that, what does it mean? That means Fermi level changes in the solids when they are warmed, means when their temperature is increased, the electrons will jump from lower state to the higher state. When the electron jump from lower state to higher state, so automatically what will happen? The Fermi level, it will shifted either up or shifted downward. Or when the electrons are added to the given system or withdraw. So what does it mean? That means when we are adding electron to the given system or we are withdrawing the electron from the given system. For example, for the we are taking the example of helium here. So helium, it has configuration of 1s2. That means both the electrons are paired in this case. Now when we add one electron into it, so in this case its valence band that will be 1s. In case of helium gas, valence band will be, here the valence band will be 1s, because this is the highest occupied level, and the conduction band that will be 2s, because this is the lowest unoccupied level. So this is not occupied over here, 2s 0. So that means the conduction band will be 2s and the valence band will be 1s. Now add one electron into it. When one electron is added into it, so it will become helium 1 negative, and what we will get? So that will be 1s2 and 2s1. Now what is the highest filled band in this case? Now that will be 2s. So that means valence band that will be shifted. So that will be, now it will become 2s. And what will be the conduction band? Now the lowest occupied level, that will be 2p now. Now there will be 2p0. So that means 2p0 is there. So the conduction band will be 2p. So that means when we are taking or when we are adding the electrons, the valence band or the conduction band, they can be shifted up. So it can be shifted up or it can be shifted down. For example, when you are taking the example of lithium, or you can take the example of sodium. So in the sodium, the last configuration is 3s1 and 2p6. When one electron is removed from here, you are making it Na positive. So in that case, the valence band, it will become now 2p. In this case, the valence band is 3s. So the valence band, it can shift it downward, it can shift it upward. So depending upon that, the Fermi level of the material that can be shifted up or can shift it down. Or in case when you are increasing the temperature, so when we are increasing the temperature, in that case also electron can jump from this to this level when we are increasing the temperature. So depending upon that, the Fermi level that can be shifted. So now let us take a short break. So till now we have understood what is the Fermi level, how the materials are distinguished in the metal, semiconductor and the insulator category depending upon the position of Fermi level.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. Now till now we have understood what is the Fermi level and how the materials can be described into three forms. One is the metal, semiconductor and insulator. Now we will calculate what is the energy associated with these levels. So that energy is known as the Fermi energy. So now definition of Fermi energy, so it is defined as the concept in the quantum mechanics that usually refers to the energy difference between the highest and the lowest occupied single particle state in the quantum system of non-interacting fermions at absolute zero temperature. So what does it mean? So that means fermions, these are basically electrons because they obey the Fermi laws. So that's why these fermions, these are the electrons over here. Now, non-interacting means they are moving freely inside the material. So these Fermi energy, you can, in the easy term, you can see that energy associated with the Fermi level, energy of the particles which is associated with the Fermi level, that energy is known as Fermi energy. Or the Fermi energy, that in the quantum mechanics, this is refers to as energy difference between the lowest level and the highest level. So this difference between the energy of the conduction band and the energy of the valence band, that is known as the and the difference between these two energy is known as the Fermi energy, and that is energy, this energy is for the fermions or the electrons. They are non-interacting because they move freely inside the material. No other collisions, and when their collisions are present, these collisions are elastic. So that's why these are taken as non-interacting fermions. At the absolute zero temperature means that all the measurements are done at the 0 Kelvin. So this is known as the Fermi energy. Now Fermi energy that can be plotted along this y-axis. So now we know that in case of metals, this is a valence band and that is a conduction band. So valence band and conduction band, they overlap with each other. So this is a case of metals, while in case of semiconductor, there is a small difference between the valence band and the conduction band, and that level which lies in midway between valence band and conduction band, this is known as Fermi level. So this is a Fermi level which divide equally the valence band and the conduction band. While when the difference between this valence band and conduction band is very large, this kind of materials, they are known as insulator, and this gap is also known as Fermi band, Fermi gap. Now, band gap. What is band gap over here? Band gap, it is defined as the difference between the valence band and the conduction band. This difference is known as band gap. So, band gap, that is a difference between the conduction band and the valence band, and this band gap is represented by the term Eg. So, what is Eg here? So, that means if this is a valence band and this is the conduction band, and the highest occupied level in between this is known as EF, and this level is known as Fermi level. Now the difference between these two, now if EV, this is known as the energy of the particle, it is associated when the particles are present in the valence band. This energy is known as EV, or you can say that EV, that is the energy of the highest occupied band or highest occupied level. So EV, this is known as the energy of highest occupied level. That energy is known as EV, or as the valence band energy. This is known as okay. Now next is the EC. This is the energy associated with the conduction band. So this is known as energy of lowest unoccupied band. This is known as energy of lowest unoccupied level, or that is also known as conduction band energy. Now the difference between these two, EC minus EV, this is known as EG. EG, that is the difference between EC minus EV, that is known as band gap energy, or we can calculate band gap of the material. Now in case of metals, EG, what is the value of EG? We know that in case of metal, most of the cases EC and EV both are at the same level, because in case of metals, valence band and conduction band, they overlap with each other. So when we are calculating band gap of the material, that is taken approximately equals to 0. So that's why metals are also known as zero band gap materials. So in that cases, it is very easy for the electrons, without application of any external force or external energy, either the thermal energy, electrons can jump from valence band to the conduction band. So in that case, band gap energy Eg, that is equals to 0. So this is known as band gap energy. And also the Fermi level, it is a lies in midway between the Fermi level. It can be in the valence band or it can be in the conduction band. While in case of semiconductors, Eg, it has value from 1.1, or you can say that from 0.1 to maximum value, it is taken to be 3 electron volt. So this is a value for the semiconductor. While for insulators, this Eg, it is taken more than 3 electron volt. So these are defined as the band gap energy. Now next is the Fermi energy. So Fermi energy for the material, so that is defined as the energy which is associated with the Fermi level, and this Fermi energy, it is equals to EF, and that is equals to EC plus EV by 2. So this is a Fermi energy of the particle, or Fermi energy for the Fermi level, energy associated with the Fermi level, or you can see that this is a Fermi energy of non-interacting fermions at absolute 0 Kelvin. So this is a Fermi energy for the particle. Now in case of conductors or insulator, they in case of metals, both are at the same level, then energy is equals to either EV or EC. So this Fermi energy, that can be calculated. Now there are some applications of this Fermi energy. These applications are like that. So this is one of the important concept in the quantum mechanics and condensed matter physics, and applications are like that because some of the phenomena like materials that can be distinguished in the three forms. Either they can be metals, conductors, insulators, or the semiconductors. Now it is used to describe the semiconductors and insulator, while free electron theory is not able to describe the semiconductors and insulator. It is applicable only for the metals, but the Fermi energy and the Fermi level, this concept is able to distinguish between the metals, semiconductor, and as well as insulator. So it is used to describe the insulators, metals, and the semiconductor. Fermi energy is also applied to explain the electric and thermal characteristics of the material. So that can be easily described over here. And also in the nuclear physics, in order to explain the stability of white dwarfs. So all these are the stars, how their mass is taken comparable to sun, but their radius is 1/100th of its radius. So all these things that can be explained by the Fermi energy, according to which in the small area, the large amount of particles or the materials, they are described over here. So they are these particles, they are trapped over there. So that's why these phenomena that can be explained over here. So by using the concept of Fermi level energy, it is very easy to describe or very easy to distinguish between the metals, semiconductors, and insulators. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.